talking about 9.3, which is the Pythagorean theorem, which our book calls the most elegant theorem in geometry. If you ask pretty much anyone, anything about geometry, they'll typically spout out, oh, a squared plus b squared equals c squared. And though that is true, you can't always use that. We can only use a squared plus b squared equals c squared, which, again, pretty much everyone knows if, and it's a pretty big if, you have a right triangle. This only works when you have a right triangle. So it's very important that if you don't have a right triangle, you don't try to use a squared plus b squared equals c squared. And with this a squared plus b squared equals c squared, your a and b are leg lengths, and c is the length of your hypotenuse. So c is always going to be your largest side, since the hypotenuse is across from that right angle. So I've got myself a right triangle. I've got a and b labeled as my legs. My c is labeled as my hypotenuse. Notice that side A is across from angle A, side B is across from angle B, and side C is across from angle C. So if those letters moved around and C is not in a hypotenuse, we just have to be really careful. So if we have a triangle and it's a right triangle, like here we have triangle ACB, then c squared equals a squared plus b squared, which is again the same thing as a squared plus b squared equals c squared. So let's try to use it. I'll tell you that we have a right triangle. I know that a squared plus b squared equals c squared, so long as these are my legs. Legs are, of course, those sides that are not the hypotenuse. And since it looks like we have our hypotenuse, I'll plug that in for C. I can plug in 3 for A or B. It does not matter since we are adding and squaring each of them anyway. So I'll square my numbers. Subtract 9 from both sides. I've got b squared equals 16, and when I take the square root, I do get positive or negative 4, but since of course we are dealing with a triangle here, our missing side is 4. And we'll see this 3, 4, 5 triangle quite a bit. It's one of our what we call Pythagorean triples. So what happens if I have 3 sides and my 2 smaller sides, when I square them and add them, they're not equal to my third side? 8 squared plus b squared does not equal c squared. Well, if that happens, if a squared plus b squared is greater than c squared, our triangle is acute. If a squared plus b squared is less than c squared, then our triangle is obtuse. And of course, if they are equal, then our triangle is right. So we're going to see this if we're just given 3 sides, no diagram, no information about angles. So if I was just given what kind of triangle has sides 5, 6, and 8, well, I know my largest side has to be C. So I'm going to set up 5 squared plus 6 squared. I don't know what the relationship is, so I'm just going to leave it as a box. Equals 8 squared. So 8 squared I know is 64. 5 squared is 25. 6 squared is 36. When I add 25 and 36, I get 61. So if I compare that to 64, well, my a squared plus b squared is less than c squared. So I know, since that falls into this category, my triangle must be obtuse. I don't need to know anything about my angles. I don't need to know anything else about my relationship to the sides, what this triangle looks like. I know that my triangle is obtuse. There's some sort of obtuse angle in there. So that's really all I would do with these. I would plug it into a squared, b squared, c squared, add a squared and b squared, see what kind of relationship it has with c squared. If we're equal, we'll be right. If we're less than, we'll be obtuse like we were here. But if we're greater than, we are going to end up being a cube. So that's all I really want to talk about for right now. We'll look at some example problems with this in class and really start applying this.